Space, for all its vastness and unpredictability, is supposed to follow a strict set of rules. We rely on the absolute nature of physics to tell us what is real and what is not, but every once in a while something drifts out of the eternal darkness that challenges everything we think we know. Between May and September, the entire world was captivated by such an object, 3I Atlas. It wasn't just another comet. It was an interstellar visitor, a traveler from the deep void beyond our solar system. From the moment it was detected, 3I Atlas became the most scrutinized object in human history. We didn't just look at it, we stared into its soul. Imagine 230 observatories spread across every continent, all pivoting our massive lenses toward a single point of light. In the darkness, we were tracking its trajectory with a precision that is almost impossible to comprehend. We're talking about an accuracy of 0.028 arcseco. NDS, to put that into perspective, it's the equivalent of sitting in New York and being able to spot a single dime sitting on a sidewalk in Philadelphia over 100 miles away. That was the level of our gaze, and during those 5 intense months of observation, the data returned something profoundly unsettling: absolutely nothing. You see, in the cold logic of the cosmos, Psilink E is a form of communication. 3I Atlas moved exactly where the invisible hand of gravity told it to move. It didn't wobble, it didn't drift, it didn't exhibit any of the errant icy behavior we expect from a typical comet. As it moved closer to our sun, it was bombarded by solar radiation, the kind of energy that should have caused gas to vent and push the object off course. Yet 3I Atlas remained steadfast. It was a silent, massive weight, indifferent to the pressure of our star. In physics, this lack of movement tells a very specific story about mass. To remain so unresponsive to the solar wind, an object must possess immense inertia. It has to be heavy, incredibly heavy. Scientists, including the renowned Avi Loeb and several international research teams, began crunching the numbers. The math led to a singular, undeniable conclusion: 3I Atlas was a behemoth. Based on its refusal to be pushed, we calculated a diameter of at least 5 kilometers and a mass of roughly 33 trillion kilograms. We weren't looking at a mere snowball, we were looking at a 33 billion ton mountain of interstellar ice and rock. It was a solid, undeniable fact. We had measured the giant, and the giant was real. We built our models on this certainty, confident that we had understood the nature of this visitor. We saw a mountain, and we believed in the mountain, but looking back, that certainty was our first mistake. We assumed that because it was heavy and quiet, it was just a typical rock from a distant star. We didn't realize that 3I Atlas was playing a different game entirely, one that would soon lead to the greatest mathematical anomaly in the history of modern astronomy. Everything we thought we understood about 3I Atlas shattered in December as the object made its closest approach to the Sun. The James Webb Space Telescope, the most powerful eye humanity has ever placed in the heavens, was locked onto its position. It was looking for the whisper in the darkness, and it finally found it. For months, 3I Atlas had been perfectly quiet, showing no signs of the outgassing that defines a comet, but now the JWST detected a tiny, subtle acceleration, a push that had been invisible to every other observatory. It was moving just 13 kilometers per day faster than gravity alone would dictate. In the grand scale of the solar system, 3 kilometers is nothing, but in the world of physics, this tiny shift was a tectonic explosion that leveled our previous theories. When scientists plugged this new acceleration data into their models, the result wasn't just a slight adjustment. It was a total erasure of reality. To understand the shock, you have to understand the math of the rocket effect. As a comet gets hot, it vents gas. That gas acts like a thruster. James Webb measured the gas shooting off the surface of 3I Atlas at a staggering 1,600 kilometers per hour. The object was losing roughly 150 kg of its own mass every single second. Now, here is where the paradox becomes a nightmare. If you know the speed of the gas and the amount of material being lost, physics gives you the exa, see the amount of force acting on the object. And if you have a specific force pushing on an object, the resulting acceleration tells you exactly how heavy that object is. When the researchers runched the numbers, the mountain we had been tracking all summer simply vanished. To achieve the specific acceleration measured by the JWST, 3I Atlas couldn't be a 5-kilometer-wide giant anymore. It had to be barely 1 kilometer, and its mass. It didn't just drop, it plummeted. It went from the 33 trillion kilograms we were so sure of in September to a mere 260 billion kilograms in December. I'll be honest with you. When these results first hit the desks of astronomers, many thought it was a typo. We are talking about a 120-fold difference, a 99% loss of mass in just 90 days. To put that in perspective, imagine you spend all summer tracking a blue whale in the middle of the ocean, only to pull it out of the water and realize you were actually looking at a goldfish, but there was no explosion, no debris cloud, no fragmentation events. 32 trillion tons of matter didn't just break off, it seemingly evaporated into the void without a sound. This discrepancy is unheard of in the history of astronomy. It suggests that the object we were so confidently measuring in the summer was fundamentally, physically different from the object we were seeing in the winter. It leaves us with a haunting question that keeps the brightest minds at NASA up at night. Did the mass actually disappear, or were we never looking at a mountain to begin with? If 3I Atlas always weighed 260 billion kilograms, then why didn't the sun's radiation push it like a leaf months ago? The math is relentless, and it tells us that between the summer drift and the winter dive, 3I Atlas didn't just change its course, it shed its very reality. When the numbers in a scientific model break this spectacularly, researchers usually look for a measurement error. But with 3I Atlas, the measurements weren't the problem, the subject was. As the 99% mass loss paradox began to circulate through the halls of academia, a chilling realization took hold. If the laws of nature can't explain why a mountain turned into a ghost, then perhaps we are looking at something that isn't entirely natural. This is where the debate moves out of the comfort of tradition, all astronomy, and into the shadows of the machine theory. Think about it. If 32 trillion tons of matter didn't actually vanish, if there was never a solid mountain of rock to begin with, then the paradox disappears. This is the argument pushed by scientists like Harvard's Avi Loeb. They suggest that our first mistake was our most basic one. We assumed 3I Atlas was a rock because it looked like a rock, but the data from December suggests something far more complex. What if 3I Atlas is actually a thin, hollow shell? Or a massive, ultralight structure, a light sail, designed to navigate the interstellar void? If the object is a hollow machine, the mystery of its mass is solved instantly. A hollow structure can have a massive visual footprint, appearing as a 5-kilometer behemoth to our telescopes while possessing almost no actual weight. It's like looking at a giant hot air balloon from a distance. It looks like a solid, heavy orb, but in reality, it's months fly empty space. This explains why, once it hit the intense heat and radiation of our sun, it was pushed around like a feather. It wasn't losing mass. It was finally revealing its true, lightweight nature. But that leads us to a darker, more haunting question. Why did it stay so silent and steady during the summer? If 3I Atlas was a light, hollow object all along, the solar pressure should have been pushing it off course from the moment it entered our system. Yet, it didn't move an inch. It drifted with the heavy, silent confidence of a 33 trillion kilogram mountain. Some theorists suggest this wasn't an accident, it was a maneuver. It was as if the object was intentionally staying quiet, perhaps using its own internal propulsion to counteract the solar wind, maintaining the sk of a harmless rock until it reached a specific point in its trajectory. It feels like camouflage. A way to drift through the silence of the galaxy looking like nothing more than a stray piece of ice, only to shed its skin and adjust its course. Using the very star it was visiting, we are like ancient sailors standing on the shore of a remote island, watching a modern nuclear-powered ship pass by. We tried to use our primitive understanding of wood and wind to explain why that floating island is moving against the current. NASA's models struggle because they are built on the binary ice of rock or gas, but 3I Atlas is showing us a third way. It is a ghost in the machine of our solar system, a visitor that refuses to be weighed by our rules. If it is a machine, it entered our system as a heavy, silent observer and lightened its load as it prepared to dive back into the eternal darkness. We spent 5 months trying to fit a masterpiece of interstellar engineering into a box labeled comet, and the box simply wasn't big enough to hold the truth. I don't know if we'll ever have a final, satisfying answer for what happened to those 32 trillion tons of matter. The universe is not a library that gives up its secrets just because we've learned how to ask the questions. 3I Atlas is already beginning its long, lonely journey back into the eternal void. And as the distance between us grows, so does the silence. We are left holding to conflicting realities that refuse to merge. On one hand, we have the summer giant, the massive, immovable mountain of ice that we measured with a precision that would make a watchmaker jealous. On the other hand, we have the winter ghost, the lightweight, hyper-responsive anomaly that the James Webb Telescope saw dancing under the sun's heat. How do we reconcile these two versions of the same visitor? Perhaps the math is simply broken, or more likely, perhaps our very definition of W hat constitutes a rock in the interstellar darkness is too primitive for the reality of the cosmos. We spend our lives trying to fit the universe into boxes, natural or artificial, comet or machine, life or dead matter, but 3I Atlas has shown us that there is a third way, a gray area where the rules of our era might not apply. What gets me is the idea that we might have shared our solar system with something truly anomalous, a piece of technology or a strange form of matter a million years beyond our comprehension, and we spent the whole time trying to weigh it with a scale made of old assumptions. We saw a shadow on the wall and tried to calculate the weight of the wall, never realizing that the shadow was the point. Whether it was a fragile, fluffy comet shedding its soul as it neared the fire, or a hollow scout adjusting its drift for reasons we can only guess at, 3I Atlas has left a mark on our physics that won't be easily erased. It serves as a haunting reminder that the silence between the stars isn't just empty space, it's a vast, dark ocean where the things we call facts are sometimes just temporary masks. As 3I Atlas moves back into the darkness, it leaves a hole in our understanding the size of 32 trillion tons, and we may never get a second chance to look inside. I appreciate you joining me on this deep dive into the heart of the anomaly. If the mystery of 3I Atlas and the missing trillions has left you staring at the stars a little longer tonight, please consider leaving a like and subscribing to the channel. Your support helps us keep the lights on here as we continue to track the unknown through the lens of history and science.